Hello and good day everyone. Okay, today we're going to discuss comparator circuits. So this is a comparator circuit for 1 bit. This so we have a bit here which we will label as A, and we will have another bit here which or switch here which we will label as B. So now this publics up since both A and B are turned off or they are equal. So if we turn them on again, both of them on, so this will be still be equal since the value is equal, which is 1 is equal to 1. So if we turn off B, now what this the value of A is 1 and the value of B is 0, so A is greater than B and vice versa. So the value of A is 0 and the value of B is 1, so A is less than B. Now let's discuss this is a 2-bit comparator circuit. This is the complicated version, and this is the shortcut or the simplified version. Now let's discuss. We will discuss this later in our prototype in Tinkercad. So in logically, let's discuss the 4-bit comparator first. So first, let's turn all the values to 0. So as you can see here, we have A is equal to B since all values are 0. So let's try 1 here. So now we have 1 here. So this is our wait. This will be our A and this will be the values for our B. So the value of our B here is 1, which means that B is greater than A. Now let's switch this on. Now we have A is equal to B. Now let's try all the values. So now I have 1. Let's try 2. Okay. So now still B is greater than A since the value here is 0 and the value here is 2. 1, 2, 3, okay, 4, 5, 6, 7, 8. So if all buttons here are switched on and all buttons here are switched off, that means the value here is 1 plus 2 plus 4 plus 8, which is equal to 15. So 15 is greater than 0. This means that B is greater than A. Now let's try here. So the value of A here is 1, meaning A is greater than 0 or A is greater than B. So let's try this and this. Now since the value here is 3 and the value here is 1, now this bulb lights up since 3 is greater than 1. So now this will become equal 4. Okay, still B is greater than 1. B is greater than A since 6 is greater than 3. Now 7 is greater than 6, so A is greater than B. Now this will both be equal, and then here A is greater than B. Even if we turn this off, A will still be greater than B since the value here is just 7 and the value here is 8. But if we turn this on, now the value here is 15 and the value here is only 8, so B is greater than A. So now it will become equal. So this is the circuit or the integrated circuit using using the 2-bit comparators here. So this makes the 4-bit comparator easier for the eyes. It's not very complicated. The connections are minimized. So still the same. The values here will still be the same. So A is greater than B. But if we do this, now B is greater than A. So now let's go to Tinkercad. Now this right here is a 2-bit comparator. Okay, now since... Okay, let's turn this off first. So this will be equal to... Okay, again, I forgot to label the LEDs here. Okay, let's start the simulation. Wow, lag. Oh, what the... Ah, wait. Okay, there. Okay, let's start the simulation. Now we have our values for our A here and values for our B here. Now if we say that this is 0 and 0 and this is 0, 0, so the values here are 0, which means A is equal to B. If we change here or we switch on, if we switch this on, now the value here is 1 and the value here is 0. So A is greater than B, so this LED lights up. Now if we turn this on, now since the value here is 1 and the value here is 1, so A is equal to B. So the LED here lights up. So this circuit compares if the values of the two bits here is greater than, equal, or less than the values or the value of the two bits here. So again, let's turn this on. Now the value here is 3. So 3 is greater than 1, so A is greater than B. This LED lights up, will light up. Now if I turn this on again, okay, the value of both these switches are 3, so 3 is equal to 3. This LED lights up. Now if we turn this off, we will see that B is greater than A since 1 here. The value here in B, our B is 1 and the value here is 0, so 1, 0 and 0, 0. If we turn this on, the value here will be 3 and still the value here will be 0, so B is still greater than A. If we also turn this on, then the value here is 2 and the value here is 3. So 3 is greater than 2, B is greater than A. Now, as you can see, the LEDs switch or change. The B is greater than A turned off and the A is greater than B turned on. Now, that's because the value here is just 1 and the value here is 2. So 2 is greater than 1, so A is greater than B. So that is all. If we turn this on, that will be equal. Okay, that is all for today. Thank you for watching.